Hey guys, welcome back to geometry. Today we're going to take another look at proving lines parallel. Now, we have seen in the past some diagrams where maybe it looks like this. They give us two lines and a transversal, and maybe they tell us something about a pair of angles or a couple pairs of angles. They tell us that those two angles are congruent, and we can use that very quickly to show that these two lines are parallel. Okay, we have a couple of properties that we can use to make it happen, and sometimes it's a couple of extra steps, but it's pretty quick and easy, and we can spot exactly what we need to work with here. However, it's not always as crystal clear as that. Sometimes we have a diagram more like this one, where there's some extra lines in there. Maybe there's some extra information in the given. Okay, and that makes it a little bit more difficult for us, a little bit more, we have to do a little bit more thinking to get the job done. Okay, but they're always going to fall back on the same basic ideas. Okay, and here's a couple of them right here. If we're trying to prove that lines are parallel, let's take out that property list and go back to the stuff that we know about parallel lines. Well, we have basically these four right here. Okay, we have the corresponding angles postulate, the alternate interior angles postulate, alternate exterior angles postulate, and consecutive interior angles postulate. Those four are basically going to be the big ones that we need. If we can show that the relationships that they describe here exist, any one of them is going to be good enough to show that the lines are parallel. So corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent, or consecutive interior angles are supplementary. If we can show any of those relationships, that's going to be good enough to show that the lines are parallel. Now, the trouble is that when we look at a diagram like this, there's extra lines. It's not as simple as two lines and a single transversal. Here, they've added a second transversal, and that can make things a little tricky for us. So what we really have to do is focus on what's going to be helpful for us, what we can use to make stuff happen. Now, good news for us is that no matter what the proof is, we always get kind of a free answer. We always list the given information first. Okay, so we're going to start out by saying that line L is parallel to line M, and angle 1 is congruent to angle 2. And I'll tell you what else I'm going to do. I'm going to put that on the diagram and make it crystal clear for us. Now, they've already put these arrows on the diagram to show that those lines are parallel. I'm just going to put them in red so that they're easier to see. Okay. Now, they also tell us that angle 1 is congruent to angle 2. Okay. Now, think about what our objective is, where we're trying to go. We're trying to show that line A is parallel to line B. Now, when I look at this diagram, I see two different transversals. I see line L as a transversal going through those two lines, and I see line M as a transversal going through those two lines. Any angle pair that we're talking about has to be on the same transversal. Since I'm only given angles 1, 2, and 3, those are really the only ones that I can work with. So I have to pick two angles that are on the same transversal. Well, the only two angles that are on the same transversal are angles 2 and 3, are both on line M. So those are the ones that I'm going to have to work with. So whenever you're working on a proof, it's a good idea to start thinking about what you have and what direction you can go. Well, angles 2 and 3, if I look at that diagram, if I really focus on just these two lines, A and B, that I'm trying to prove are parallel, and this transversal, M, and I really just focus on those, angles 2 and 3 are are alternate exterior angles. Okay, so I'm going to make a note of that. I'm going to say angles 2 and 3 are alternate exterior angles. Okay, now, remember what we said in our list of properties. Alternate exterior angles, if I can show that alternate exterior angles are congruent, that means that those lines are going to be parallel. So that's going to be my objective. I'm going to try to show that those two angles are congruent, and that'll be enough to show that those lines are parallel. Well, take a look at some other information that we have. We are given here lines L and M are parallel. Now take a look at angles 1 and 3. Angles 1 and 3 are corresponding angles. If we go back to that property list, we can see that if we have parallel lines, that means that those corresponding angles are going to be congruent. So, since those lines are parallel, my next statement, I can say that angle, and there we go. My next statement, I can say that angles 1 and 3 are congruent, because the corresponding angles postulate. And we can abbreviate angles postulate. Okay. Now, angles 1 and 3 are now congruent. Remember what we wanted to say? We wanted to say that angles 2 and 3 are congruent. So a step along the way, let's think about this. I have angle 1 and 3 are congruent. I have angles 2 and 1 are congruent. So both angles 2 and 1 are congruent to both angles 2 and 3 are congruent to angle 1. We have a property that says we can cut out the middleman and say, hold on here, we can cut out the middleman and say that angle 2 is congruent to angle 3. So maybe we need to go back and take a look at that list of properties. Okay, what property says we can cut out the middleman? Okay, well, the transitive property says if two values or figures are equal or congruent to the same value or figure, then the first two are equal or congruent to each other. Okay, so right here I have if A is congruent to B and B is congruent to C, then A is congruent to C. We're cutting out the middleman, not B. That's what the transitive property says we can do. So now, list the transitive property as our reason. Okay, now we have angle 2 and 3 are congruent. Angle 2 and 3 are alternate exterior angles. That's enough to say that line A is parallel to line B, okay, because of the alternate exterior angles postulate. And we can abbreviate alt ext angles postulate. Now guys, that's it. Okay, we use the properties that we have to get the angles that we want congruent, and that's enough to show that those lines are parallel. So we can say QED, and this proof is complete. Okay, let's take a look at another one. Now I have this diagram. And this diagram is a little bit more complex. There's some more lines floating around, and I'm given some information about the measures of these angles. Okay, they don't tell us that anything's congruent. They don't tell us that any of those angles are the same. But they want us to prove that line RS is parallel to line PN. Okay, that's what we want to make happen. Now, as a matter of fact, they just say segment PN. So just this guy from P to N and just this guy from R to S. They want us to show that those are parallel. But it's important to remember that even though we are only looking at those segments, those lines continue indefinitely. So I have those lines that go on forever. And when I look at this diagram, okay, we can also see that there is a transversal that intersects both of those lines. So I think that's probably going to be my focus. I'm really going to try to zero in on this. Now here's the trouble point though. When we look at this diagram and we see all those pieces, they haven't told us that anything's the same. Okay, they have, however, given us this piece of an angle, this piece of an angle, this piece of an angle, and this piece of an angle. So we're going to have to figure out a way that we can put those together to show that those lines are parallel. Well, let's start from this. We always know one place that we can always begin. We're going to have to list our given information. Okay, so I'll tell you what we're going to do. Since I can do this right here, I'm going to copy all of this and list it as my given. So statement number 1 is always going to be that given information. And the reason is always going to be that it was given. Okay, that's kind of a free answer. Every time we always know that's where we have to start. All right, well, now let's start thinking. Okay, let's get that brain going here. If I want to show that these lines are parallel, okay, what I can see here when I look at this is that they've given me these two pieces, this piece and this piece. Now those together make an angle along this transversal. They make this whole angle. And they've given me these two pieces, which together make this whole angle. Guys, those are alternate interior angles. So somehow I want to see what happens when I put those together. Okay, well, let's think about this. Over here, I've got 39 and 101. If I add those together, I'm going to get 140 degrees. Over here, if I take 98 and 42, and I add those together, I'm going to get 140 degrees again. So those two angles have the same measure, which means that those angles are going to be congruent. And if those two angles are congruent, those alternate interior angles are congruent, that's going to be enough to say that those lines are parallel. Okay, the trouble is I have those lines in pieces. So I need a property that allows me to put those together. Well, let's take a look at our list of properties here and let's scroll through it. And division, distributive, reflexive, transitive, semi. Hey, angle addition postulate. It says that the sum of the measures of all the pieces of an angle is equal to the measures of the whole angle. Okay, look at this diagram. If I add angle 1 and angle 2 together, I get the measure of the whole angle. Well, that sounds like something I can use right here. So that's what I'm going to do. I'm going to say that the measure of angle NPO plus the measure of angle OPS equals the measure of angle NPS. Okay, if I add this little 39 degree plus this 101 degree, that equals that 140 degree angle. Okay, now we can also say the same kind of thing, okay, with the angles down here, with the 98 and the 42. Okay, I need to change those angles names a little bit, so we'll say angle PSQ. Okay, that's this one, the 98 degrees. We'll say angle QSR. Okay, that's this little 42 degrees, and if I add those together, that's equal to the measure of angle PSR. Okay, this whole angle over here, the one that I've arced in that red. Now, we said that the property that allows us to do that, to add those pieces together, is the angle addition postulate. And that should be reason number 2, not reason number 3. Okay, now, here's the trouble though. If I want to show that these are congruent, I want to show that those two red arced angles are the same, somehow I need to get these numbers involved. Well, from the given information, they've given us those numbers. So what we can do is we can substitute. In place of measure of angle NPO, we can say 39 degrees. In place of the measure of angle OPS, we can put 101 degrees. Okay, and we'll keep this as the measure of angle NPS. It will stay that that's what it's equal to. And tell you what, since we're going to do the same kind of thing with these angles, let's put this on the same step. Okay, in place of the measure of angle PSQ, let's put 98 degrees. Okay, and in place of the measure of angle QSR, let's put 42 degrees. Okay, but let's keep it equal to the measure of angle PSR. Now what we need is a property that says that we can do that. Well, what property says that we can replace one piece with an equivalent piece? To take a look at our list of properties, or maybe we know off the top of our head, but we can always take a look if we need to. The property that says that we can replace stuff is the substitution property. If A is equal to B, then A may be used in place of B in any equation. Okay? You can replace a piece of an equation with an equivalent piece. Well, that's substitution. Okay, the substitution property. Okay, and we can abbreviate property, but we don't want to abbreviate substitution, okay, because if I abbreviate it as just sub, that could be the subtraction property. Okay, we want to make sure that we're very clear. So we'll leave that as the substitution property. Okay, now let's clean this up a little bit. What happens when I add those two together? Well, if I do 39 plus 101, we said that that's 140 degrees. And that's equal to the measure of angle NPS. Okay, and we can do the same thing for these two. 98 plus 142 is equal to 140 degrees. And that's equal to the measure of angle PSR. Now, once again, that was just substitution. Okay, we did the addition. Okay, these two together, 39 plus 101 is 140, so we replaced it, and that's the substitution property again. Now, take a look here, guys. I have that both of these angles are equal to 140 degrees. And if they're both equal to the same thing, we have a property that says we can list them as equal to one another. We talked about this on the very last proof. What property says we can cut out that middleman and say that those two angles are equal to each other? That was the transitive property. Okay, now we're almost there. I have just stated that these two angles that are arced in red up here, that those two angles have the same measure. The measures are equal. That's not, however, the exact same thing as saying that they're congruent. Okay, I need to actually list that as a separate statement. So I'm going to come down here, statement number 6. Okay, I'm going to say that those angles are congruent. Okay, so I'm going to take away the m's. We're not talking about the measures anymore. And instead of saying that they're equal, I need to say that they are congruent. Okay, remember, equals deals with numbers, congruent deals with figures. Now, we need a property that says that we can say if their measures are equal, that means those angles are congruent. Well, guys, that is the definition of congruent angles. And we can abbreviate, we can say def of congruent angles. And always just make sure that you're not listing it as equal. There's a difference between equals and congruent. Okay, so make sure you put that little squiggly on top of the equal sign and turn it into a congruent statement. Now, if those two angles are congruent, okay, what we talked about at the very beginning is those angles being congruent, they are alternate interior angles. And we had that property list that says, I'm down here to the stuff on parallel lines. Okay, if alternate interior angles are congruent, that means those lines are going to be parallel. So we can use the alternate interior angles postulate to say now that those lines are parallel. So statement number 7, we can say that RS, or segment RS, is parallel to segment PN. Okay, and remember we want to list that as segments. Okay, so we put those bars on top. Our final statement has to be exactly the same as what we're asked to prove. Okay, so statement number 7 here, or reason number 7, okay, we can use the alternate interior angles postulate. It says that if those angles are congruent, that means that those lines are parallel. And there we go. Our proof is complete. So sometimes it's quick and easy. Sometimes we just look at the diagram. There's not a whole lot of steps involved, maybe a little bit of transitive property, and we have enough to show those lines are parallel. Sometimes it takes a little bit of creativity, and we have to think a little bit. Okay? And that list of properties, guys, is what's going to allow us to really do that. So we talked about this in class. You need to have a copy of this list that you can refer to. And we're going to continue to add to this list. It's already, what are we looking at here? 5 pages long. Okay, And we're going to continue to add to this. The more properties that we add to this list, the easier and the more proofs that we're going to be able to complete. Okay? Make sure we have that list. Make sure we know where things are on that list. And don't be afraid to get creative. Okay? If you have questions, make sure you ask. Take your time. Focus on the pieces of the diagram that we need. Okay? So I like to highlight them. Sometimes it's helpful to sketch a separate diagram that has just the parts that you need. The important thing, guys, we need to be able to recognize those angle pairs. Those are what makes everything happen.